Good afternoon, everyone. This is Ms. Cobb coming to you with another lesson. Today, we will learn a little bit about electrical energy. So, let's get started.
Have you ever wondered how a flashlight works? Sure, it seems pretty simple. All you have to do is move a switch or press a button and ta-da! The light comes on. But what really makes the light go on? Right you are, Squeaks. It's electricity that makes the light go on. You probably already know something about the electricity that powers things in your house. Well, the electricity in a flashlight comes from the batteries that are inside. Electricity flows from the battery to the light bulb, and when the electricity goes through the bulb, the flashlight lights up. But the electricity doesn't just jump from the battery right to the bulb. In order to get from the battery to the light bulb, the electricity has to go along a specific path, and that path is called a circuit. If you listen to the word circuit, it kind of sounds like a shape you might know. Let's name some shapes and see which one sounds like circuit. Triangle? No. Square? No. I know. Circle. And if you look at a circle, you can see that it goes around and doesn't have any spaces or gaps in it. And that's true of a circuit too. There can't be any spaces in the path that electricity takes to get from a battery to a light bulb. In a circuit, if electricity doesn't have a path to travel on, it stops. It's a little like a train on train tracks. When there's no more track, the train stops. So let's see how a simple circuit works. The battery is what we call the power source. That is, it's where the electricity comes from in this circuit. Electricity flows from the power source on the path of the circuit. And a lot of the time, that path is made by some kind of a wire. The circuit then leads to whatever we want to power. In this circuit, that's a light bulb. As the electricity goes through the bulb lights up. The electricity leaves the bulb and flows back through the battery. Then it follows the circuit all over again. As long as there are no spaces in the circuit, the bulb will stay lit. But what if we want to turn the light on and off? Then we have to break the circuit, which means we need to put a space in it somewhere to stop the flow of electricity. So we use a switch. A switch allows us to make a space in the circuit if we want to. When the switch is on, there's no space in the circuit and the light bulb is lit. But when we move the switch off, we open up a space. The electricity can't jump over the space, so it can't reach the light bulb, and the light bulb stays off. Okay, so I'm going to try to build my own circuit using some of the parts that I have here. I have a power source, this battery, and a wire for the electricity to travel through, and a little light bulb. If I arrange everything just so, it kind of looks like a circle, but the bulb isn't on. That's because I haven't connected all of the pieces together. Remember, there can't be any spaces in the circuit, so I'll connect the wires to the power source, then I'll connect one wire to the bulb. And when I connect the other wire to the bulb and complete the circuit, the bulb lights up. Now I'm going to add something else to make it work a little more like a flashlight does. I have this part that looks like a button, and I'll put it right here. And look, the bulb is lighting up. That means that there are no spaces in the circuit. Okay, Squeaks, let's press the button and see what happens. Hey, the light bulb went off. That means when I press the button, the circuit is incomplete, which means that I've created a space. And when I let go of the button, the circuit is complete again. When I press the button, the electricity from the battery can't cross the space, so it can't get to the bulb and make it light up. The button is a switch, kind of like the switch on a flashlight. If you look around you, you'll find circuits just like this one that are everywhere, powering all kinds of things around you. Cars, trucks, and buses all use a circuit with a battery to get started. And circuits run through your refrigerator too, and in all of the other machines in your home that use electric power in order to work. Inside devices like phones and computers, which you're using right now, there are very, very small circuits that use the same basic setup as the one we just built. Large or small, it takes a circuit to carry the power that we need to get going. Thanks for joining us on SciShow Kids, and special thanks to Google Making Science for helping us make this video. Do you have a question about something? Grab a grown-up and ask them to help you. Leave a comment down below or send us an email to kids@scishow.com. Thanks, and we'll see you next time here at the fort.
Okay, so that was a short video on electrical energy. One type of electrical energy are circuits, power circuits, and those are things that you can actually find throughout your home. So let's learn a little bit more about different types of electrical energy, shall we? So I see that you should notice a little boy with a fan, and then there's a smaller fan with batteries. So let's see what is going on. Nico is excited for the next section. It looks like they've made it to electrical energy. He observes a fan, batteries, and an electrical outlet at this station. Look at his hair. Nico's hair stands up when he touches the Tesla plasma ball. Let's explore electrical energy to see what it is all about. So in this lesson, you're going to be able to identify examples of electrical energy. And also tomorrow, you will be recording examples of energy sources from electrical energy. Feeling the charge. Examples of sources for electrical energy are all around you, and you might not even know it. Let's observe some different examples that you might not be able to identify around you. One example would be battery. Batteries are used in a lot of our daily lives. They're used in cell phones, flashlights, remote control, toys, and lots of other examples. Batteries are examples of a source of electrical energy. So any type of battery that you use in your home or the batteries you even see in the stores, that is considered electrical energy. Also, there's batteries in cars. So that's a source of electrical energy. Static. Have you ever rubbed the balloon against yourself and then touched something metal? That shock you feel is an example of an electric shock. Static electricity is produced when you rub objects together. When you rub certain objects together, you are producing an electrical charge. Power plant. Power plants are big factories that generate energy. Your home, grocery store, library, sports complex, hospital, and many other buildings rely on electrical energy provided by power plants. So we have three examples. We have battery, static, and power plant. Those are three different examples of electrical energy. Sources of electrical energy are pretty neat. You can't see the electrical energy, but the electric charge it produces is something that you can definitely feel. It is important to be safe around electricity. You wouldn't want to get shocked. Some things like batteries, power plants, lightning, and other sources of electrical energy are sources of electrical energy because they actually produce electrical energy. Other objects like your computer, television, or vacuum cleaner use this electrical energy to work. In this activity, you will practice identifying different examples of objects that use electrical energy. Stretch your brain and think of all the different examples of objects that use electrical energy around you. Okay? You can make toast in this object that uses electrical energy. So we got a cell phone, laptop, iron, that looks like a power drill, a TV, microwave, refrigerator, toaster, and then that looks like they're looking, oh, it's a fan. So I'll give you some think time. And if you would choose fan, you are correct. Let's see what happens next. So it says to continue to practice what you know about identifying sources of electrical energy with this activity. Remember to try your best. So I'm going to select all images to show examples of energy sources for electrical energy. I have a hammer, lightning, batteries, a power plant, and a family riding a bike. So I know it's not a hammer. Lightning does have electricity in it. Batteries are an example of electrical energy. And a power plant. So the three examples that I chose were correct. Recording examples. Is it important to be able to record all the examples of electrical energy that we have identified? When you record examples, it helps you remember what you have learned. It also helps you share what you've learned with others. It says, observe the pictures and identify examples of energy sources for electrical energy. When you identify an example, you can record it in a notebook. We don't have an actual science notebook, but you can record it in your notebook or on a sheet of paper. So we have a battery, that would be an example. Static electricity, that is an example. And the power plant, that is another example. Find the source. We have observed many different examples of sources of electrical energy. I wonder if you will find similar examples around you. It's time to find out. Practice like a scientist. It is time for you to go into exploration with a trusted adult. And this is something that you can do around your house. You're going to search for examples of energy sources for electrical energy. Print the examples of energy sources activity sheet and complete part 4. You do not have to print that out. You can simply write that on a piece of paper. And you can also write the examples of energy sources table on a piece of paper as well to share out. And they give us examples, and this is with the where you will go to copy and write on a sheet of paper if you do not have a printer. And you're just going around looking for electrical energy sources in your home. You can look for 2 to 3 different types. With the help of Nico, you are able to practice identifying examples of electrical energy. These examples are all around you, and you might not even realize it. It is important to record your examples so that you can remember the information you have gathered and share with others. Now you can identify examples of electrical energy, and you can be able to record examples of energy sources for electrical energy. And again, this could be something that you also can take note of tomorrow because we are continuing with the lesson with electrical energy. Self-check review. Continue to practice what you know by identifying and recording examples of electrical energy with the activity below. What is electrical energy? Is it a form of energy where you can see light, a form of energy where heat is created, A form of energy where an electric charge is created, or a form of energy where sound is created. And I think it's a form of energy where an electric charge is created. I'm going to submit. Looks like I was correct. Let's go for the next one. Identify the object that uses electrical energy. We have a computer, shoes, clothes, hanger, table. Give you some think time. If you chose computer, you are correct. Last slide. Identify the source of electrical energy. We have a side table, couch, batteries, carpet. Give you some think time. If you said batteries, you are correct. That is an example of an energy source for electrical energy. So your assignment, which you will do tomorrow, and we'll be working that together during our live tomorrow afternoon, will be completing the electrical energy activity. It says quiz, but it's really just an activity. And so until next time, we'll continue to learn about electrical energy tomorrow, and stay safe, guys. Bye-bye.